respond. Did I tell you that I will be giving you some questions or like a quiz or something like that today?
Yes, teacher. Yes, teacher.
Right. Which lessons did I say I will give? First and second. Did you prepare yourselves for that? Did you study?
Yes, teacher.
Okay, great. I won't be starting it. I won't be doing it right now, but we will be doing it. මට අමතක වෙලා තිබේ ඔයගලන්ටද grade 10 class එකකටද කිව්වේ කියලා, but I suppose I told both of you. Okay. Anyhow, we will start with where we finished, and at some point in the middle, mama ek quiz එක කරනවා. Okay. All right. So, we were doing waves, right? Where were we in waves? Where did we last do in waves? Class is recording, no? Yes, Lamai. Let me also get the note. Waves. අපිට sound ඉතුරුයි මට මතක විදියට නම්. Did we finish? Why are you all like not saying anything? Did we finish the electromagnetic spectrum?
Yes, teacher.
Give me a second. We finished electromagnetic spectrum. We started sound also. Ne? I was talking about the hyla tree frog, and I was saying like we were having a small discussion. Ne? Was it big sound like a cricket's like a sound, humans vocal code, and then I also showed you a video of how sound propagates. Are api video ka longitudinal waves propagate when a video. ඊට පස්සේ අපි we even talked about that electric bell story, right? That activity. Can somebody confirm? Yes. Okay, then that means today is the last day of the lesson. We only have a very little bit of the lesson to do. Did I give you the biological processes? No, I haven't written anything on the board yet. Did I give you the biological processes PDF? I haven't. Okay. I should have. Api fourth lesson ki varayada. We did the fifth lesson. Okay, no worries. We'll since we don't have the note for the sixth lesson, which is a big lesson actually. I was planning to do it today, but I forgot that I didn't send you the note. Kamak nehimunot, we will do the seventh lesson. Seventh lesson is a very short lesson. We will be able to finish it really soon. And as soon as we are done with it, next week we can start the sixth lesson, which is the biology lesson. We also have to do a little bit of questions. Mama Vadiyama questions karan natu. I'm stalling it a little because once we are done with the entire syllabus, we will be doing past papers entirely. So we could save some time for that if we finish the syllabus soon. But randomly, as I said, today I'm doing a mini quiz. ඒ වගේ අපි randomly එක එක questions කරන්න පුළුවන්. So always be prepared. Huh? All right. Let's go to waves. In waves, we talked about the electric bell activity, and then I think after that only we have to talk about today. Okay. Is Vihan in the... No. Okay, no worries.
Good evening, teacher.
Okay, Ashwita, now it's sorted.
Yeah, teacher.
All right, okay, great. We just started, huh?
Okay, teacher.
Okay, so Lamai, before we start, how was your week? What did you all do this week? Did you all have exams? How was it? Exams. Okay, how was your exam? Did you all have the upcoming Monday? Some of you all must have already finished the exam. Some of you probably are during the exams, and some of you might have exams in the coming weeks. How was science? Who had science already? How was science? If anybody finished science? Exam is on May 5th. Mayamdilage coming Tuesday, all right. May 5th, all right. So you even got marks. Some of you have even gotten marks. The marks are very good, huh? Very good. That's nice. Others also let me know when your exam is happening. And I would also like to see your papers, because I know that you get the MCQ paper and the essay paper to take home, right? It would be very helpful for me and for all of us together if you could share some photos of your papers. Structured එක නැති වුණාට කමක් නැහැ, because that's with the teachers. But once you get the marked paper, you can even send the structured paper, photos of that.
Teacher, we got the O-level structured paper.
Mm-hmm.
Like O-level structured paper. I mean, like
The
they
structure.
give structure.
Right. I think in most papers, they have gone more or less similar to the O-level paper. You get like 40 MCQs, 4 structured, and 5 essay questions, right? Science marks will be given next week. Okay. So, Hamom, Api, like, I want to tell you some. Okay, that's good. Good marks, huh? Very good. If you have 85 above, like 80 above, 85 above, again, can I safe zone එකේ තමයි ඉන්නේ. හැබැයි ඊට අඩුයි කියලා ඔයගොල්ලෝ discourage වෙන්න එපා. It's okay. We have time. හැබැයි we have time කියලා don't take time for granted also. මොකද time කියන එක මෙහෙම බලද්දි මෙහෙම බලුවම යනවා. Right? In no time, it will be August, July. We will be starting past papers in July, August. And it's December, you will be writing your exams, right? Time goes real fast. So don't take time for granted. But at the same time, if your marks are a little low, or if you still didn't get your marks and you sat for the exam, and like, let's say you didn't feel confident, ඔගන්ට තේරෙනවානේ මම පාඩම් කරාද නැද්ද කියලා. සොකට ඔගන් දන්නවා මට confident ද නැද්ද කියලා. Confident නැතුව exam ලියපු කට්ටිය discourage වෙන්න එපා. Marks අඩු කට්ටිය discourage වෙන්න එපා. අපිට තව time තියෙනවා. හැබැයි ඒගොල්ලන් time granted ගන්නත් එපා. මොකද දැන් පටන් ගත්තොත් time තියෙනවා. හැබැයි තව පහුවෙන්න හිටියොත් එimhe time නැති වෙනවා. මං ඉස්සර grade 10 ඉඳන්ම සහ grade 11 පටන් ගනිද්දිම ඔයගලන්ට කිව්වා ගොඩක් මට හම්බෙලා තියෙනවා ළමයි last minute පාඩම් කරන්න අරගෙන කරගන්න බැරි වෙලා හරි struggle කරලා හරි ගොඩක් regret කරපු කට්ටිය. Right? So ඒගොල්ලන් like අන්තිම මාස දෙකේ වගේ තමයි they feel like okay, O levels, I have to study. But sometimes that time period may not be enough, because unfortunately your syllabus is quite heavy, not just science, for all the 9 subjects, right? So එතකොට මාසෙකින් දෙකකින් මුළු syllabus එකම cover කරන එක බැරි නැහැ, හැබැයි අමාරුයි. ඒතර මාර්ම stress එකක් එනවා, and a lot of workload. and it'll be difficult, right? And ඊට පස්සේ අන්තිමට ඔක හරියට කරගත්තේ නැත්නම් you will be like full of regret කරන්න ඕනේ නැහැ නේ අපිනේ when we have so much time in front of us. So please keep that in mind. May par exam එක හරි ඔයගොල්ලෝ හොඳට කරා නම් good, if you got good marks good, but if you got not very satisfactory marks, or if you are not feeling confident for the exam, ඒක ගැන හිත හිත දැන් worry වෙලා discourage වෙන්නේ නැතුව, you know what's coming for you, right? දැන් අප්‍රේල් මාස ඉවරයි. ඒක හින්දා ඉක්මනට හරි track එකට වැටෙන්න පටන් ගන්න දැන් වැඩ කරොත් දැන් පටන් ගත්තොත් මාසකින් දෙකකින් you will be on the right track, and then ඊට පස්සේ shape එකේ කරන් යන්න තියෙනවා. හැබැයි last minute right track එකට වැටෙන්න ගියොත් එimhe you won't have enough time. Okay, so please keep that in mind, and also keep in mind that අපි මේක කරන් යනකොට ඉස්සරහට we are all together in this, right? I'm teaching you, you're learning, yes, and also at the same time we are discussing, and you ask questions, I answer. Samhala some questions that I don't know the answer and I find the answer from somewhere else. Then I also learn certain things. And keep in mind that you also have to support each other, right? So let's make it a friendly competition, right? So ඒ කියන්නේ ඔයගලන්ට question එකක් හම්බුනොත් එහෙම ඒක group එකේම share කරන්න. ඒක මම ගිය batch එකකටත් කිව්වා ඒගොල්ලන්ට ටිකක් කරා ඒක. ඔයගලන්ට ඒක shy නේ group එකේ messages දාන්න. එහෙම shy වෙන්න අවශ්‍යතාවයක් නැහැ because it's all us, right? ඔක්කොම grade 11 අපේ මේ ළමයි ටිකම තමයි ඉන්නේ. And I'm there, Miss Divya is there. But there's no reason to be shy. If you find any question that you struggle, ඒක මට personally දාන්න no problem. Personally දානවට වඩා I would prefer if you post it in the group itself. Then we can have a little discussion on the group itself and everybody will be aware. I think that would be very healthy for all of us. We all have to support each other, and everybody should get good grades. Everybody should get an A. A is your goal. Okay? A is the goal. මොකද කාටවත් බැරි කට්ටිය නැහැ මෙතන. I'm familiar. ඔයගලන් සමහරට දන්නේ නැතුව ඇති, but I not only know your names, but I also know you up to a certain extent, even though I may not have seen you. Right? මම ඔයගලන්ගේ නම් ටික මම කොහොමද දන්නවා, but නමුත් එක්කම ඔයගලන් interact කරන විදිහත් එක්ක I have a certain understanding about you. Right? ඒකෙන් මට තේරෙනවා that all of you have the capability to go for an A. අනිවාර්යෙන් හැමෝටම පුළුවන් because it's not that difficult. මම ඉස්සර කියනා වගේ what you like you think it's difficult, but difficult syllabus එකවත් ඒකක් ගන්න එකවත් නෙවෙයි. ඕගලන් time manage කරන විදිය, ඕගලන් පාඩම් කරන ටික manage කරගන්න විදිය, අන්න ඒව තමයි බලන්න ඕනේ. අන්තිමට ඔක්කොම එකතු කරගත්තොත් it's difficult. But he means that if you tackle part by part, that's not difficult, right? Getting an A is not difficult if you take it slow, step by step. And එන්නේ කිඳ තමයි මම කියන්නේ දැන් පටන් ගන්න ඕගොල්ලන් හරියට track එකට වැටලා නැත්තම් මොකද දැන් පටන් ගත්තොත් ඔයගොල්ලන්ට step by step යන්න වෙලාව තියෙනවා. නැත්තම් පහුවෙන්න ගියොත් එහෙම it's going to be too much for your head, too much for you. Right? එහෙම වෙන්න ඕනේ නැහැ නේද? අපි relax එකේ O level කරන්න ඕනේ. I don't want any of you to be in stress, in like I don't know නිකන් මාර මොළුවට tension එකක් අරගෙන එහෙම වෙන්න ඕනේ නැහැ because you all are still children. Right? ඒකින්ද හරිම ඒක stress එකක් නැතුව relax විදියට O level කරන්න නම් දැන් ඉඳන් හිමින් සැරේ step by step කරගෙන යන්න ඕනේ. Otherwise as I said, there will be too much pressure at the last minute. That's not good for you. Okay? With that in mind, let's start waves. Let's almost end waves. Apita, okay, speed of sound. Now I hope everybody has the note with you. Okay. Ekath ekkama I want to add one more thing. The මේ කාලේ your attendance has to be very regular. ඒකින්ද මට එහෙම attendance ගැන ලොකු මට සමහර වෙලාවෙ මතක හිටිනවා ඒවා මම මිස් දිව්‍යාට කියනවා check කරන්න කියලා. But otherwise she is the one who's marking the attendance. එතකොට මම ගිය සති කියන්න නැති ඔයගලන්ට attendance 3 weeks වලට වඩා attendance නැත්නම් you will be removed from the group. It doesn't matter like fees කියන එක නෙවෙයි මෙතන බලන්නේ ඔයගලන් කියන්නේ ඔයගලන්ට හොඳ reason එකක් නැත්නම් if you don't have a reasonable excuse unless that you have to attend to classes, right? එහෙම නැත්නම් that's going to be a problem because I can't be taking responsibility for a student who's not coming to the class regularly. එකත් මතක තියාගන්න මොකද පාඩම් කරනවා recording බලනවා ඒ ඔක්කොම හරි but sometimes being present class එකේ මේ වෙලේ live ඉඳගෙන මේ discussion එක live කරන එකට compare කරන්න බෑ recording එක බලන එක කියන එක හොඳට මතක තියාගන්න. So unless it's absolutely unavoidable, please join to the class and be present here. මේකට join වෙලා වෙන වැඩ කර කර හිටියත් ඒත් වැඩක් නැහැ. So join to the class and be present. ඒ commitment එක ඒක තමයි first step එක. Right? Being present. And then comes the rest of it. Okay. During lightning, we first see the lightning strike. Then we hear the sound of thunder. Okay. Do you all have experience of this? Do you all have experience of this before?
Yes, teacher.
Yes. So, especially I think the last few days it was raining heavily and I heard some areas it was thundering and lightning. So, එතකොට ඔයගලන් ගොඩක් notice කරලා ඇති මුලින්ම තමයි අකුණ ගහන්නේ. මුලින්ම තමයි lightning strike එක. As soon as you see lightning, you know, then තව චුට්ටකින් it'll thunder. තව චුට්ටකින් ගොරවනවා කියන එක ඔයගලන් දන්නවා. That is because you first see the lightning strike and then after that thunder follows. Why is that? Because lightning can a light. It's a light. Light is what kind of a wave? Light can මොන වගේ wave එකක්ද? Is it a mechanical wave or an electromagnetic wave?
Teacher, what did you ask?
The question is light a mechanical wave or an electromagnetic wave? Is light a mechanical wave or an electromagnetic wave? Quickly tell. I have one answer, another answer.
Electromagnetic.
Okay, and another answer.
It's a mechanical wave.
It's actually electromagnetic wave. Light කියලා කියන්නේ හැමලෙම visible light because that is a light, the part of light that you can see. So part of the electromagnetic spectrum that, I mean, when you look around, you see everything because of light. So lightning strike also, that is a part of visible light. White light එකක් තමයි එතන එන්නේ. So that is an electromagnetic wave. If you want, you can just write it here. This is මෙතන තියෙනවානේ ඒක. This is electromagnetic. But sound is what kind of a wave now? Sound is what kind of a wave? Yes. It is a mechanical wave. So these two are very different, because of that. Anyhow, now electromagnetic spectrum එක ගැන කතා කරද්දී අපි කිව්වා speed of light and speed of electromagnetic waves are always not just speed of light lamai. Light is a part of electromagnetic spectrum. All electromagnetic waves have this speed, which is about 3 into 10 to the power 8 ms minus 1. So imagine කොච්චරක්ද කියලා? That would be 3, 1, 2, 3, 4, 5, 6, 7, 8 ms minus 1. එතකොට 300 million meters in 1 second. That's how fast lightning travels. But what about the speed of sound? That's so less. It's only about 350 ms minus 1. It can take a second to only like 350 meters. But light, 300 million meters in 1 second. So we can see a very clear difference in the speeds of light and sound. That is exactly why we see light before sound, because light travels faster than sound. Is that clear, Lamai? Give me a thumbs up. Others? Okay. Now, we are going to compare the speed of sound. I have a few questions. Does lightning affect to laptops? Yes, it does. Memai, lightning laptops were to affect when with the keypack, you know. One is, let's say, laptop is like plugged to the socket again. Charge when of course it will be affected. Why is that? Because when lightning strikes, electric cables වලට lightning වදිනවා. එතකොට අපේ ගෙදර තියෙන voltage එක එකපාරට spike වෙනවා. Domestic, we will be learning that exactly in lesson 10. But එතකන් අපි generally ගත්තොත් එහෙම අපිට grid එකෙන් national grid එකෙන් electricity එනකොට සාමාන්‍යයෙන් 230 volt වලට වගේ තමයි එන්නේ. That's the general voltage of electricity that we receive to the domestic circuit. But during lightning, if lightning strikes, sometimes there could be a huge spike. Because of that spike only, sometimes the trip switch gets turned off. Right? That's why the trip switch gets turned off, because the trip switch is designed in such a way that if a larger voltage comes, it will automatically switch off to protect your electric circuit. ගෙදර තියෙන electric circuit එක protect කරන්න ඕනේ හින්දා ටක් ගාලා එයා off වෙනවා. Okay. ඒක අපි ඉස්සරහට කතා කරනවා 10th lesson එකේ. So එතකොට ඒ spike එක වෙලාවට trip එකත් off වුනේ නැත්තම් and I mean trip එක off වෙන්නේ spike එක උනාට පස්සේනේ. ඒතර ඒ වෙද්දි වෙන්න තියෙනවා වෙලා ඉවරයි සමහර වෙලාවට if your device is plugged to the charger. එතකොට it's not just your laptop, any other device that is plugged to the domestic electric circuit might be like fried කියන්නේ damage වෙන්න පුළුවන්. Because our high voltage supply kinda part a large current එකක් යනවා laptop එක through. In this case we are talking about a laptop නේ. So එතකොට ඒකත් එක්ක of course laptops will get like damaged because of the lightning. ඊට අමතරව සාමාන්‍යයෙන් another thing is that during lightning, you should disconnect. Like, if let's say you have dialogue TV or POTV or like those connections, or if you have Wi-Fi routers, those also should be disconnected, because these Wi-Fi routers and all that, they have this ability to like capture signals. Ne, ඒගොල්ලෝ පුළුවන් atmosphere එකේ තියෙන signals capture කරන්න. ඒතර ඒකත් එක්කම like lightning උනත් ඒව through earth වෙන්න පුළුවන්. Lightning කියලා කියන්නේ ළමයි an extra amount of electrons, because lightning is current. Lightning එක current light එකත් එක්කම current එන්නේ. Right? Current කියන්නේ electrons. Electrons හැමලෙම හදන්නේ balance වෙන. They try to earth. Remember අපි grade 10 වල ඉගෙන ගත්ත current electricity වල. Right? So the extra electrons always try to go to the earth. ඒතර ඒගොල්ලන් තියෙන මොකක් හරි තැනකින් earth වෙනවා. හිතන්න ලොකු ගහක් තිබ්බා කියලා, උසම තැන ගහක් කියලා. So they will earth from the tree. The tree එක චුට්ටක් burn වෙනවා, but it's okay. But let's say you're in a desert, there are no trees or anything, you are the tallest item in that area. එතකොට ටක් ගාලා ඒ extra charges ටික ඔයාගේ ඇඟෙන් තමයි earth වෙන්නේ. That is when you get an electric shock. Likewise, anything around you could be used by the lightning strike to earth extra electrons.
Used to have this happen in real life?
Yes, of course, it has happened. Yes. Let's say like හිතන්නකෝ වගේ dialogue TV or ලොකු රවුම antenna එක තමයි නිකන් ලොකුවට උස්සට තියෙනවා කියලා. So sometimes lightning might earth through that. So ඒක සාමාන්‍යයෙන් power supply එකෙන් disconnect කරනවා කියන්නේ dialog route antenna එක router එකට connect කරලා තියෙන්නේ. So router, if you disconnect it from the electric circuit, wouldn't be a problem, right? So ඒ වගේ Wi-Fi routers ඒ හැම එකක්ම switch off කරන්න ඕනේ. ඒ අරෙන්න sometimes if your laptop is summoning, like if it's not connected to the plug, there's a very low chance of getting your device fried. Again, it's lightning heavily outside කියලා. ඔයාගේ laptop එක charge එකට ගහලා නැහැ. It's just like this, you're just using it without plugging to the charge. එතකොට එන්නේ direct strike එකක්. ඒක නම් ටිකක් rare, but it could happen. ඒ කියන්නේ ඒ area එකේ සාමාන්‍යයෙන් ළඟින් වගේ කියන්නේ ඔයාගේ laptop එක ළඟටම වගේ හරියන විදිහට lightning strike එකක් ආවොත් මේ extra charges ඔයාගේ laptop එකට ඇවිල්ලා laptop could be fried, but that's not very common, right? Very common නැහැ කියලා කියන්නේ it's very rare, but that doesn't mean that it won't happen. So the best option would be not to use any devices during lightning. නැත්තම් lightning වෙලාවට plug එකකට ගහලා නැත්තම් lightning strike එකක් වදින්න තියෙන chance එක අඩුයි. Phones and laptops හැමලේම අපි charge එකට ගහලා නෙවෙයි use කරන්නේ. But එහෙමයි කියලා වෙන්නේ නැති වෙන්න බෑ. Sometimes, I mean, it could happen. Who knows, right? So ඒකින්ද the safest thing is not to use any devices. Now look at this. Speed of sound at 0 degrees Celsius in dry air is about 330 ms minus 1. Speed of sound at 30 degrees Celsius in dry air is about 350 ms minus 1. But in both the cases, we're talking about dry air. Dry air කියලා කියන්නේ ළමයි water vapor අඩු නැත්නම් water vapor නැති air. Because if you take generally air has a lot of water vapor. ඒක තමයි අපි humidity කියලා කියන්නේ. If you take areas like I'm mostly familiar with Colombo. Colombo වගේ wet zone areas ගත්තොත් එහෙම humidity වැඩි සාමාන්‍යයෙන්. There's a lot of water vapor in the atmosphere. But if you go to like dry zone, like let's say Hambantota or even the northern areas. So Jaffna, yes. So in those areas, the humidity is low. So the water vapor in the atmosphere is quite low. එතකොට චුට්ටක් dry, but අපි dryම කියලා කියන්නේ when water vapor is very very low, almost zero. So අපි සාමාන්‍යයෙන් අර idea එකක් ගන්න අපි dry air වලට තමයි කියන්නේ, but practically it's not always dry air. Because if you take atmospheric air, it always has water vapor. Anyhow, both dry air, this is 0 degrees Celsius, this is 30 degrees Celsius. At 0 degrees Celsius, speed is 330. At 30 degrees Celsius, speed is 350. Now see, when the temperature is increasing, speed of sound has increased. Speed of sound has increased with temperature. So this is very important because sometimes they ask this in MCQs. Right? So keep this in mind. When temperature increases, speed of sound waves in air. Please change that. As temperature increases, speed of sound waves in air also increases. Okay. Is that clear, Lamai? Give me a thumbs up if it's clear. All right, give me 1 second. Okay, sorry, Lamai. All right, so I hope that's clear. Then speed of sound in water. Now we then temperature clear out kara. Let's move on to the next one. Speed of sound in water is about 1400 ms minus 1. This is about 4 times the speed of sound in air. අපි දන්නවා air වල ගත්තොත් around 350 වගේනේ. 330 to 350. But in water it's 1400. It's much higher. But if you take the speed of sound through a steel rod, that is 5000 ms minus 1. I think we discussed something similar to this last week also. අපි කිව්ව එක එක mediums වලදී කොහොමද speed එක කියලා. I told you, right, when a train is approaching, if you're just standing by the railway, sometimes you may not hear it. But if you keep the ear on the rail, you might hear the sound of the train approaching, because that sound travels faster through the solid, which is the railway, rather than through the air, right? ඒක practically කරන්න එපා, because of obviously for safety reasons, but that is something that can be observed. ඒ කියන්නේ speed of sound in air වලට වඩා the speed of sound in water is higher. And if you take the speed of sound through solids like steel, that is higher than speed of sound in water. Okay? One second. All right, but will you be staying in the class recently? All right, whiteboard note I will send. When I was in grade 9, a science says that phone. Actually, මම අර කියපු කතාවම තමයි. ෆෝන් එකකට lightning එන්නේ නැහැ. මං කිව්ව ඒක very rare, right? ඒ කියන්නේ ෆෝන් එක plug එකට ගහලා තිබ්බොත්, charge වෙන ගහලා තිබ්බොත්, lightning වදින්න තියෙන chance එක ගොඩක් වැඩි. But unless it's plugged to the charger, if you're just using it, there's a very low chance that it'll get a lightning strike. But let's say හිතන්න මොකක් හරි හින්දා window එකක් කඩලා තිබ්බ කියලා හිතන්නකෝ. එතකොට ඒ ළඟම lightning strike එකක් වැදුණා කියලා හිතන්න. Sometimes those extra charges may travel to your phone. Because මේ ඔක්කොම electric circuits නේ. The phone also has an electric circuit. So electricity interact කරනවා හරිම ලේසියි. Right? So chances are low, but that doesn't mean that it won't happen. But if your windows are all closed, would be okay. But I advise not to use any electronic device during lightning, unless it's absolutely necessary. Okay? Hari, එතකොට, so this is the important thing. Speed of sound in air වලට වඩා speed of sound in liquids higher. ඊට වඩා speed of sound in solids higher. So we learned about 2 characteristics of sound, නේද? එකක් තමයි when temperature increases, speed of sound waves in air increases. Next one, speed of sound waves in air is less than speed of sound in liquids. Speed of sound in liquids is less than speed of sound in solids. Is that clear, Lamai? Excuse me. Okay. Now let's talk about characteristics of sound. Who's doing music for aesthetic subjects? For like the third bucket? Either Eastern or Western music. Others? Okay. Have you heard of the term pitch? English literature. Okay. Have you heard of, even if you are doing literature, like before you come to the O-level grades in from grade 6 to grade 9, we have like a little bit of everything, the dancing, Western music, Eastern music, tibbada. Wait, I'm confused. From grade 6 to grade 9, do we have all the subjects?
Yes, teacher.
Yeah, but still we have to select, no? Yes. You can choose one. Right. Okay. I got it all mixed up. Because I remember I was like, I did Western music from grade 6 until O-levels Western music. But I remember going to like the dancing classes, but it was because my friend was there. So my memory got twisted. Anyways, so anyhow, ඔයගලන් කොහේ හරි අහලා තියෙන pitch කියන word එක. So pitch is one of the characteristics of sound. So do you have an idea about what pitch is? Sometimes we say, මෙයා off pitch sing කරේ, මෙයා නම් perfect pitch එකට sing කරා. And there's a movie called Pitch Perfect. Then sometimes we say high pitch. Sometimes we say low pitch. I can sing okay, but not very nicely. My two best friends used to sing very well. Anyways, so we say that, right? High pitch, low pitch, off pitch. එහෙම කියලා හරියට ගොඩක් use කරනට මේ අනිත් දෙකට වඩා we use pitch a lot. What exactly is pitch? ඔයගන්ට තේරෙන විදිහට කියන්න බෑ. සිංහල word එක හරිය කිව්වත් කමක් නෑ. Pitch is like the exact note that the person is singing, no? So, අපි ගත්තොත් එම for an example, if you are doing Western music, let's say middle C, or let's say සිංහලෙන් ගත්තොත් සා කියන note එක, සාරිගාමා එහෙම තියෙන සා කියන note එක. So that note has one pitch. But ඔයා හිතන්න piano එකක් කියලා piano එකේ මැදම note එක play කරොත් that has one pitch. But ඔයා ඊට වඩා keys 10ක් විතර එහායින් play කරොත් එම that's a different sound. That's a different pitch. තවත් 10ක් එහායින් play කරොත් that's a different sound. That's a different pitch. Right? So like that, then also, frequencies, yes. So also, let's say, මේ එක C කියන note එක මම piano එකෙන් play කරාම එක sound එකක් එනවා. But if I play it from the guitar, I get a different sound. That same note, if I play from, let's say, මොකද තව එකක් කියන instrument එකක්, let's say violin, you would hear a different sound. ඒ කියන්නේ instrument එකෙන් instrument එකට sound එක වෙනස් වෙනවා. And sometimes, let's say this one particular note, මම මෙම හිමින් press කරනවා piano key එක. එතකොට පොඩ්ඩියට sound එක එන්නේ. මම high-ින් click කරනවා නෙවෙයි press කරනවා. So එතකොට high-ින් sound එක එනවා. Likewise, sound can be manipulated නේද? හැමලෙම වෙනස් කරන්න පුළුවන්. අපිට එක එක sounds play කරන්න පුළුවන්, එක එක instruments වලින් play කරන්න පුළුවන්. We can play like slowly, like a very less sound, or we can play it like a louder sound, right? එක එක විදියට we can change sound. So these are the characteristics of sound. Okay, එහෙම තමයි අපි එක එක sounds වෙන්වෙන්ව distinguish කරා. All right. So in this lesson, we are going to be learning three main characteristics of sound. One is pitch, then we have loudness, then we have quality of sound. We talk about each and every characteristic individually. Okay. Go to the next page of your note. Okay, first characteristic, pitch. In this activity, in this activity, a hacksaw blade. Have you all seen a hacksaw blade? Let me show you a hacksaw blade. Definitely you have seen, sometimes you may not know the term. You have seen blades like this, no? Sometimes a construction කරන හට ගැන බස් ලගාව හැම තියෙන්නේ. මේකනේ පොඩි blade එකක්. Have you all seen hacksaw blade? Just like a strip of blade, but it's a little longer, right? Yes. So what we are going to do is we are going to use a hacksaw blade, and I have fixed it between two blocks of wood. See here, actually now here, this is one block of wood, and this is another block of wood. So I have like tightened or fixed the hacksaw blade between the two blocks of wood so that මෙතනින් hacksaw blade එක move කරන්න බෑ. මෙතනින් tightly fix කරලා තියෙනවා. උඩිනුයි යටිනුයි there are two blocks of wood. All right. At the first instance, when it is vibrated, a certain sound is generated. ඔන්න මෙතනදී එක sound එකක් generate වෙනවා. How do we generate the sound? මෙහෙම hacksaw blade එක fix කරලා අපි එක පැත්තක් මෙහෙම මේ we just what do you call it? මේවා කරනවා. එතකොට ඒක මෙහෙම move වෙනවානේ. Did you get what I mean? Like you just cause a vibration to the hacksaw blade, right? Then it will vibrate and you will actually hear a sound. Okay, so you will hear like a certain sound. In the second instance, what I'm going to do is that I'm going to increase the length of the hacksaw blade. දැන් මෙතන හිතන්නකෝ මෙන්න මේ එළියට expose වෙලා තියෙන 10 centimeters කියලා. Here I'm going to take it out a little bit more so that the length of the hacksaw blade vibrating will be higher. Now it will be 15 centimeters. Now I can hear that there is a different sound with a higher pitch. High pitch sound එකක් ඇහෙන්නේ කලින් එකට වඩා. So what did we do? We took a hacksaw blade, we fixed it between two blocks of wood with a certain length of the hacksaw blade coming out. And that length here is 10 centimeters. So length of the part of the hacksaw blade that is vibrating is 10 centimeters. And I cause a vibration, and when it's vibrating, you hear a sound. In the next instance, I'm going to take it out a little bit more so that the length of the hacksaw blade vibrating will be 15 centimeters. Now it will be higher. Now when I cause a vibration, I hear a different sound with a different pitch. It will be a higher pitch. Okay. So lamai, pitch depends on frequency. This is very, very important. When we were learning about sound, then pitch can lamai physics neme. Pitch can a musical term, right? Pitch is a characteristic of sound that is not exactly a scientific term. But pitch is equal to frequency. And frequency we know very well, it's a scientific term. Neither. So අපිට pitch කිව්වම pitch කියන්නේ නිකන් general term එකක්. It's not a scientific term. But when we say frequency, we know very well because it's a scientific term that we learned. So pitch is actually equal to frequency. Pitch depends on frequency. හරිද? එතකොට අපි ගත්තොත් එහෙම 1 second, let me show you. Let's take something like, okay, I took a piano here. On the piano එකේ හරියට මැද තියෙන C note එක තමයි middle C කියලා කියන්නේ. So if you are doing Western music, it's nothing new. So this is middle C. අපි කියමු මෙයා තමයි middle C කියලා. Now when I press on this key, a certain sound is generated. A sound එකේ frequency එක 256 Hz. Frequency is 256 Hz. Now what I'm going to do is, I'm going to click the C that is after that. ඒ කියන්නේ මෙන්න මෙතන තියෙන C එක click කරනවා. We call this higher octave C, HL terms දැනගන්න ඕනේ. But when I click on this, a different sound is generating, and that frequency is 512 Hz. Now I clicked on two notes. I got two different frequencies. That means I got two different pitches. මෙයාගේ frequency එක 256 Hz. So ඒකට අදාළ විදිහට pitch එක හම්බ වෙනවා. මෙයාගේ frequency එක 512 Hz. That means frequency is higher. Therefore pitch will also be higher. Okay? Is that clear, Lamai? Up to this point, do you all have any questions? Okay. Then, Lamai, we have this thing called oscilloscope. Oscilloscope එකේ වෙන්නේ නිම screen එකක් තියෙනවා. from the screen, you can see the shape of the wave. This is very useful actually. If you now, there's this wire and the other end of the wire is connected to a microphone. So if you hold the microphone to any sound, the wave pattern that is related to that sound will be seen on the screen. So oscilloscope is a very interesting instrument. මම කතා කරන එක මට මයික් එකක් අල්ලලා ඔසිලොස්කෝප් එකෙන් බැලුවොත් එක එක විදිහට මම කතා කරන එකට අදාළ සවුන්ඩ් පැටර්න් එක එනවා. ඔසිලොස්කෝප් එකේ ස්ක්‍රීන් එකේ හැදෙනවා. You can hold that to any sound and you will get the pattern on the screen. So what I'm going to do is I'm going to hold the mic to two different pitches. Two different pitches means two different frequencies. Why? Because pitch is equal to frequency. May I have a low pitch? Low pitch means low frequency. High pitch means high frequency. Now, can you first tell me, let's revise a little bit. What is frequency? What is frequency?
The number of oscillations in a unit time.
Number of oscillations in a unit time. What do others think? Same or different? Yeah. So it's going to be, one second, what is this? So it's the number of oscillations in a unit time. 1 second. Okay, Lama. So frequency, as you all said, is the number of, can you all hear me? Thumbs up? Okay. So as you all said, yes, frequency is the number of oscillations or number of vibrations or number of waves in a unit time. Let's say a second. බලන්න මෙතන waves are quite far apart. මෙහෙමනේ තියෙන්නේ, මෙන්න මෙහෙම තමයි waves තියෙන්නේ. Like this. But if you take here, the waves are closer to each other. Compared to A, in B, waves are closer to each other. A to comparatively B, well, waves are closer to each other. Therefore, definitely it has a higher frequency. Meage frequency is lower. Therefore, pitch is lower here. Here the pitch is higher. Because we know pitch depends on frequency. So what is this other thing? Longer period, shorter period. What is period now? You all remember what period is? What is period, Lamai?
Lisa, what did you ask?
What is period?
In the periodic table
No.
group,
In waves, what is period?
the time taken,
Time taken for what?
the time taken for a wave to travel. Well, no, the time taken for a particle to travel in a way.
Partially correct. I'm also getting answers in the
I
chat
am
box.
confused whether the
Yes, it's okay. So particles don't move forward in a wave. They are just moving up and down or back and forth, right? But anyways, period the time taken for one wave, right? Just one. We know one wave is one wavelength, right? So the time taken for one wave is period. That is T. And we learned this relationship. No, we learned something like this. Frequency equals 1 over period. So if frequency is higher, obviously period should be lower, right?
lagging.
Can others hear me? Am I lagging? Just checking if it's a connection issue from my end. Yes, can you hear me or am I lagging?
You were lagging a little while ago, teacher. Now we are okay.
Now okay. Right. Okay, great. So we learned this relationship, Nene. Frequency equals 1 over T. 1 over period. So එතකොට මෙතන denominator කියන්නේ මෙයා ඉන්නේ. So මෙයා අඩු වෙනකොට frequency වැඩි වෙනවා. So here frequency is higher means period is lower, shorter period. Here frequency is lower means period is higher, so longer period. Okay. Up to that point is everything clear, Lamai? Okay, so remember very well that pitch is dependent on frequency. Pitch depends on frequency. Very, very important. Okay. Next, let's move on to loudness. Loudness is pretty straightforward if you talk about the meaning, because loudness is loudness. Loudness can sound when you're hearing a sound. If you hear the sound very like in a quiet way, it's not very loud. So the loudness is low. If you hear the sound very loudly, that means the loudness is high. Right? That is what loudness means. Now, loudness depends. Now, we said in the earlier one, pitch depends on frequency, right? Here, loudness depends on amplitude of the wave. Amplitude, we said, is the maximum displacement of the wave from the center position, right? Madena kochara kudata yanawada, the maximum. And madena kochara kyatata yanawada, the maximum. That is amplitude, right? Do you all remember amplitude? Give me a thumbs up if you remember. Okay. Balanna, if you look at this one, here the amplitude is much higher. In P, the amplitude is much higher than Q. Waves waves are short. So in P, the amplitude is higher than in Q. Amplitude vary can a loudness vary. The reason is because Lamai, amplitude higher means if the amplitude is a lot, that means that particular wave is carrying more energy. More energy හින්දා තමයි යාට වැඩි සද්ද ඇහෙන්නේ. That's why it's loud. But if the amplitude is low, that means the energy that it carries is also low. Then you hear a very low sound. It's mentioned here, when amplitude is higher, it carries more energy, therefore loudness is higher. When the amplitude is lower, it carries less energy, therefore loudness is low. So here we have used two sounds, and we have gotten the wave patterns on the oscilloscope. So මේක බැලුවම හොඳට පේනවානේ මෙයාගේ loudness එක මෙයාගේ amplitude එක වැඩි like this. P ගේ amplitude එක වැඩි. Amplitude වැඩි කියන්නේ loudness උත් වැඩි. මෙයාගේ ගත්තොත් it's the amplitude is shorter. So low amplitude means low loudness. ඒ ටිකම තමයි මෙතන තියෙන්නේ. So is loudness clear to you, ළමයි? Give me a thumbs
Yes,
up.
teacher.
So as I said earlier, pitch depends on frequency. Remember, this is very important. Loudness depends on amplitude. Okay. Pitch depends on frequency and loudness depends on amplitude. All right. What is the third characteristic of sound? Quality of sound. This is quite interesting. Let me get the note to the whiteboard. Okay. Then, I'm going to play the same sound. Let's say middle C කියලා. I'm going to play middle C. I told you අර piano keyboard එකේ middle C එකේ frequency එක 256 Hz. මම මේ middle C එක play කරනවා piano එකේ. Middle C කියන්නේ මේ frequency එක play කරනවා piano එකේ. Right. And the same frequency I'm going to play on the violin. And the same frequency I'm going to play on, let's say, flute. Okay. So, in all the three instruments, when I'm playing this frequency, I'm going to use the same loudness. Loudness means amplitude, right? Same loudness, that means amplitude is equal. Balanna, frequency got equal. Same frequency. Same frequency means pitch is also equal, right? So pitch is equal. Loudness is also equal. But three different instruments. Will you hear the same? Okay, same pitch, same loudness. But piano, violin, flute, three different instruments. Will you hear the same sound from the three instruments, or will you hear different sounds from the three instruments? What do you think? What do you think? Others? I'm a answers done, but I will try to show you a little image. Yes. Let's see what are the answers we have in the chat box. Okay, Windy, all right. But make sure that you request the recording, get it. You listen to the recording, you take the notes, and also you follow the whiteboard note. Okay? Okay. Different. 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 The question is same pitch ne me tunam on the same pitch because same frequency means same pitch. And I have said that it's the same loudness. But three different instruments. Will the three sounds be equal or different? Will the three, yeah, the sounds will be different. Why? Because piano can play when එක විදියකට violin can play when තව විදියකට flute can play when තව විදියකට. Wow, if you close your eyes, you hear the three sounds. Wow, සමහර instrument එක දන්නේ නැතිව but you can clearly say මේත් ඇවිල්ලා sounds තුනක් කියලා කියන්න පුළුවන් නේ. අන්න ඒ quality එකට තමයි අපි කියන්නේ quality of sound කියලා. Even if three or two sounds have the same pitch, same loudness, but the source is different. Piano, the violin, the flute, the hacksaw blade, the මොකක් if the source is different, we can clearly distinguish. අපිට මෙයා මේ sounds දෙකක් කියලා කියන්න පුළුවන්. Right? That is what we call the quality of sound. And ළමයි quality of sound depends on waveform. Waveform කියලා කියන්නේ shape of the wave. Okay. So on your note you can see ne piano එකක බලන්න sound එක එන විදිය something like this. හිතන්න middle C කියලා. The shape of the wave will be something like this. Something like that. I mean, it's not the most accurate. I'm trying my best, but ඔන්න ඔහොම එකක් තමයි එන්නේ. That's a piano. Violin එකෙන් play කරද්දි කොහොමද එන්නේ? ඒකත් ඔය diagram එකේ තියෙනව නේද? Something like this. ඔන්න ඔහොම එකක් තමයි එන්නේ violin එකේ. Flute එකේ එනවා again something a little different. ඒක නම් note එකේ නැහැ. I googled it. ඔන්න ඔහොම sound එකක් තමයි එන්නේ. Wave එකක් තමයි එන්නේ. Bana same pitch. May waves very gana shape because these shapes are just like sketches that I drew. They're not the real shapes, but something similar to this. So same pitch, same loudness, but three different sources, three different ways of generating sounds. ඒකින්ද ඒගොල්ලන්ගේ shape එක cathode ray or oscilloscope එකේ වෙනස් විදියට ආවේ. Shape of the wave. That means that property, we call it quality of sound. Right, let's read a little. Same note, same pitch is played from piano and violin with the same loudness, but see two different instruments. Even though both sounds have the same frequency and same loudness, same amplitude, sounds generated by the two instruments are different. We can identify the sound of each instrument. Quality of sound is determined by the waveform. This is the shape of the wave. In the given diagram, waveform of same frequency played with same amplitude from three instruments are shown. Bana me instruments තුනක් මේවල tuning fork එකක්. Tuning fork එක ඔයගලන් දැකලා තියෙනවද අර මේ YouTube එකේ හිටින healing sounds or you know, what do you call that? අර මෙහෙම bowls පාවිච්චි කරලා they use this like some like healing sounds වගේ නිකන් අර අමුතු.
So, but we It's like the shape is like a fork, but in a bigger size.
Yeah, so there can be different sizes in the tuning fork. So if I were to show you a little video,
I saw a video, teacher, like they're tapping the tuning fork, and when they're dropping slightly into the water is evaporating, like bubbles are forming.
uh, evaporating. So that
A
means that
sound,
the energy is
like
much higher.
bubbles are forming with a sound.
Right. So that means the energy is much, much higher. So I shall show you a little video for tuning fork just so that you have a better understanding of what this tuning fork is. Let me screen share. See, this is a tuning fork. I don't know if you can hear me.
Here's how to use a tuning fork in less than 10 seconds. Grip it, tap it, tune it. Oh.
That's for like Karanekang Ekamara, calming sound with it, like anxiety, like stress, Mara calming sound with it, Tibetan healing sounds where they use like tuning fork. But let's look at this one.
Isha, I saw the one in the beach. There, it displayed me.
Yeah.
In the screen, like with the background of beach, there is a something, right?
This one, oh yes.
The hidden power, that one, I think.
Yeah.
Ah,
This
the
one.
below one.
So when meva give healing sounds wage. So sometimes let's say you want to calm down, you can just click on this, make a chutak you actually calm down. It might work, I don't know, it might work. So api scientifically physics with use karna make an example like that. You can hear the sound. See? A ping pong ball but can you hear the sound? So tuning forks are sizes there are different sizes and different like a lot of tuning forks. Some tuning forks set gaddi guda. So each tuning fork generates a different sound, different frequency. Anyways, let's jump back to what we were discussing.
Isha, does it verify according to the size or to the design?
According to the size, according to the length, actually.
So two tuning phones with equal size will like give the same sound, right?
Yeah, we'll give the same sound. Yes. Main length this is the part that is vibrating. Just like in the hacksaw blade earlier, we only consider the length of the part that was vibrating. So here also we are considering that in the tuning fork. If any of you are planning to do science for A levels, in physics, there's a lot of but there's more about tuning forks. And they might even take you to the laboratory, the physics laboratory at your school. And they will like show different shapes and different sizes of tuning forks. And you can check each and every one, the sound that is being generated. Because I remember when I was doing A levels, I checked that. We went to the physics lab in our school. You did that practical in school. That's great. So that's good. So you might have a better understanding. But mama A levels කරන කාලේ තමයි මට මතක physics lab එකට ගිහිල්ලා අපි එක tuning forks sound එක බැලුවා. එතකොට ඇත්තට මේ sound එක මාරු විදිහට වෙනස්. Okay? So මේ එකම note එක but this is tuning fork, this is violin, this is piano. Same pitch, same amplitude, but three different sounds because the waveform is different. Is that clear, Lamai? Give me a thumbs up. Others? Okay, give me a second. Kwanita? Okay. I want you all to try a little question. Let me see first of all if we can try it yet. අපිට තව ultrasound කරන්න තියෙනවානේ. Say 20, no? Did we do any exercise from the textbook exercise, Samay? Did we do any questions from that? Did we do any exercise from did we do any questions from the textbook exercise? Quickly tell. No. Okay. Go to page 101. Can you all try the second question? Second, it's a little long. The end B of the metal blade AB shown below is clamped to a table. But like Roman number 1, 2, 3, 4, it was a 5. Okay, there's a little bit of sound, characteristics of sound. I will put the question on the board as well.
Is your page number?
Page number 101. But please remember that ඕගලන්ට ඕන විදිහට literally කරන්න බෑ. I won't give you too much time. Around like 5 to 10 minutes වගේ දෙන්නම් time එක. But when I say stop, you have to stop. ඒක ඉක්මනට කරන්න ඕනේ. Okay, start. Lamaya, while you do this, give me 2 minutes. Huh? I will be I won't be here, but in 2 minutes I will be here. If you have any questions, keep them. I'll let you know when I'm here. Lama, which Roman number are you all doing now? Can you all hear me? Which Roman number are you all doing now? Others? Okay, a lot of you are in the fourth one. Last one, okay. I have a question. Now, if I do like this, can you see the whiteboard? Can you all see the whiteboard? Do all of you have textbooks? Because I need to set up something. So while you do the question, I will be setting that up for the quiz. But you have your textbook, right? So please refer to the
Isha, are
textbook.
we having the quiz today?
Yes. That is a plan. Miss Divya has made arrangements for the quiz also. Let's see. Quickly do the questions first. Lama, I think the time is up now. Have you all finished? Others? Others? Okay. That means we can discuss. The end B of the metal blade AB shown below is clamped to a table. It is made to vibrate by a force applied to end A. So we have applied a force to end A, and therefore this metal blade will vibrate. Give a rough sketch to illustrate one vibration generated in the blade. How did you show this rough sketch? How did you show this? Did you show it as a graph? Like this. And this. This is displacement. This is time. Or no, sorry, this is the distance. If you all remember, wavelength we drew this graph, right? We refer to a graph. They are asking one vibration. One vibration means one wave. So one wave now we know this is one wave. And then A kiyanne then in a position. So A is this. Then C and D are the maximum displacement. So C can meter displacement, D can meter displacement. Okay. So this is one way of representing, one way of writing the answer for this question. Did you all do it this way? Did you all draw a graph like this to show the answer?
Yes, teacher.
Okay. Yeah, others? Because there's another way. Yes. Question yes. Like a sketch. So question somehow you may have understood in a different way.
But teacher, I drew both sketch and the
Right. Okay. It's okay. Let's see. So this blade, when you apply a force at A, move it. Move with it. This is the maximum displacement C. And then it will move back to this and then back to this way. This would be D. Maximum displacement other way. So this is how the blade moves. Methanida methanter. Methanida methanter. And then methanida methanter. And then methanida methanter. That would be one way. So now you have to show arrows also. So I showed both ways because the question is not the clearest. It's not very clear. So you may have understood in different ways. So both these answers are correct. Okay. Describe what is meant by the amplitude using the points marked as A, C, D. What is amplitude? What is amplitude? Big letter. Ogal, you answer kya lamai? Fast. Otherwise, we are taking too much time now. The maximum displacement. And they have said C and D are maximum displacement. Therefore, amplitude how do we describe it? We can say here, I will write the answer here so that you can correct if your answer is, check if your answer is correct or not. Amplitude is the maximum displacement of particles in the wave motion. Here, C and D represent amplitude. So you can just say like this. C and D are the amplitude points. A, C, A, D is A to C, A to D. Yes, that's also okay. That's clear, no? Excuse me. Then if 50 vibrations take place during 5 seconds, find the frequency of vibrations. What is the frequency, Lamai? Excuse me. Okay. කොහොමද අපි frequency හොයන්නේ? We said frequency හොයන්නේ අපි frequency equals number of vibrations. Here there are 50 vibrations. Correct, yes. We divide by the time, which is 5 seconds. So 50 divided by 5, we get 10. So answer is 10 hertz. Okay, next one. Up to that point, is it clear? Give me a thumbs up, everybody. Others? Okay. Vibrations of the metal. Okay, now let's move on to the next one. Huh? Vibrations of the metal blade gives rise to compressions and rarefactions in air. The මෙයා මෙහෙම vibrate වෙනකොට යාගේ වටේ ඉන්න air particles වල compressions and rarefactions හැදෙනවා. Do you all remember what compressions and rarefactions are? What are compressions and rarefactions? Quickly tell. We did this last week. We even watched a video. Yes. Sound particle, correct, but partially. Sound particle, sound is not particle. Sound is energy, right? It's a wave. So what happens is that when sound is propagating, air particles, when they come closer, we call those compressions. When they go far apart from each other, we call them rarefactions, right? So, මෙහෙම metal blade එක vibrate වෙනකොට එතන ළඟ ඉන්න air particles ටිකත් compressions rarefactions වලට වෙනවා. Right? So, to what physical quantity related to sound waves in air is the distance between two compressions equal to? So, what are the physical quantities we learned? We learned frequency, we learned period, we learned wavelength, amplitude. ඒව තමයි අපි ඉගෙන ගත්තේ නේ. එතකොට what is the distance between two consecutive compressions equal to? I got one answer already. Others? Others, what do you think? I got another answer. I got a third answer. Good. It's wavelength. Compressions කියලා කියන්නේ එක වගේ දෙන්නෙක් නේ එක වගේ දෙන්නෙක් ළඟ ඉන්න තැන් දෙකක් නම් ඒ දෙන්න අතර gap එක we call it the wavelength. Remember, if you take a transverse wave, these are crests and these are tropes. Gap between two crests, we call it wavelength. Gap between two tropes also we call wavelength. ඒකෙම longitudinal waves වලත් මෙහෙම තිබ්බට these are actually compressions. These are මොකද එක්කෙනෙක් compressions. එක්කෙනෙක් rarefactions. Generally අපිට longitudinal waves මෙහෙම draw කරන්න බෑ because you know longitudinal waves move like this. But අපි සාමාන්‍යයෙන් කියනවා distance between two compressions is equal to one wavelength. Okay? So here Answer is wavelength. Okay. What is the sound characteristic that depends on frequency? What is the sound characteristic that depends on frequency? Pitch, yes. Good. What is the sound characteristic that depends on amplitude? Good, loudness. The same musical note was played with several musical instruments. Each one could be identified separately. What characteristic of sound? Quality of sound. Good. Very good. Okay, any questions up to this point before we move on with the lesson? Is everything clear, Lama? Give me a thumbs up. Okay, great. All right. Let's move on to the note. I said that we will finish the lesson today. We are going to finish the lesson. I think we might have to do the quiz on a different day. That means next week. Reason එක තමයි I can't set it up on Zoom. Miss Divya set it up, but I can't access it through Zoom. I tried my best, I suppose. One second. Okay. මං හිතන්නේ අද මට ඒක access කරගන්න බැරි වෙයි වගේ. දැන් මේ ඔයගොල්ලන් question එක කරපු මුළු වෙලේම that's what I was trying. Because even though it was already set up, I couldn't run like a කියන්නේ පාස පටන් ගන්න කලින් චුට්ටක් එක මේ වැඩ කරන්න කොහොමද කියලා මට හරියටම බලා ගන්න බැරි වුණා. So I'm trying to use Zoom itself for that. Zoom එකේ there's an option like a poll option where like when I give the question or Zoom එකේ answer එක click කරන්න පුළුවන් and then at the end we can get the marks and all that. So කමක් නෑ අද අපි lesson එක ඉවර කරමු. Next week we will definitely start with the quiz. We'll start with the quiz. Okay. All right. I have a question. Is the quality of sound known as timbre? Yes. Actually, then api O-levels වල ඉගෙන ගන්න ඕනේ quality of sound කියලා. However, the real term is timbre. Timbre කියන එක තමයි හරිම term එක. හැබැයි ඒක අපේ syllabus එකේ නැති හින්දා we won't properly learn that term, but since you asked it, yes. Timbre කියන්නේ quality of sound වලටම තමයි. Okay. Can we hear all the sounds in our surroundings? We think we can, but we cannot. Why is that? I'll give you a very good example, right? Firecrackers. Firecrackers, what are we singling? You know, Ratinya, and this, like all this sound, noise generating, festive stuff like firecrackers, all this. Anyways, when let's say Ratinya, let's say the firecracker. When you light a firecracker, it creates a blast, right? It's quite too loud for you, but it's bearable for you. අමාරුයි තමයි but අර එක ගොඩාක් අමාරු නෑ අර bear කරගන්න පුළුවන්. හැබැයි ඔයගොල්ලෝ notice කරලා තියෙනවා especially now since we just passed the අවුරුදු season, during the අවුරුදු season there's a lot of Ratinya going on. Have you all noticed that all these like maybe the dog at your home or like the street dogs, they bark a lot because it's very difficult for them. Have you all noticed this? Yes. So I'm personally very against firecrackers. I believe that, I don't know, mom සාමාන්‍යයෙන් ලොකුවට festive නිකන් අර ඒ වගේ pollution වෙන ඒවාට වැඩියම කැමති නැහැ. Especially firecrackers වලට කැමති නැත්තේ because my dog is suffering and also අපේ පාරින ඔක්කොම බවු ටික suffer කරනවා, and I really, it's very sad for me, right? Because people really don't know much about it and they just do it. But and also people, sometimes certain people, they don't care about animals also. So because of all those reasons, they just do it. But ඒක ඇත්තටම අපිට හිතා ගන්න බැරි තරමට ඒක බවුන්ට අමාරුයි. Okay? That is because when you light a firecracker, there's a lot of sound generated from it. හැබැයි අපිට ඔය ඔක්කොම සද්ද ඇහෙන්නේ. We have a certain range. අපිට ඇහෙන්නේ only sounds between 20 hertz to 20,000 hertz. I will show you a video also for this. අද පෙන්නනවා එක මම. අපිට ඇහෙන්නේ 20 hertz to 20,000 hertz වෙනකන් විතරයි. But if you take, let's say when you light a firecracker, මේ range එක ඇතුලේ තියෙන sounds ටික we will hear. But outside this range we won't hear. But the dogs can hear more than that. They can hear like up to 40,000 hertz වගේ ඇහෙනවා. ඒත් ඒගොල්ලෝ අපිට වඩා ගොඩක් ඇහෙනවා. That's why compared to us they suffer more. Okay? Compared to us they suffer more because they hear many other noises from the firecracker that we don't hear. Okay? So and also like ඔයගලන් කියන්නේ මෙහෙමයි. අපි සාමාන්‍යයෙන් ලංකාවේ ඇත්තටම pollution අඩුයි. ඔයගලන් ඒක දන්නවද කියලා මම දන්නේ නැහැ, but if you take many like other countries, developed මෙම Europe වල සමහර රටවල් තියෙනවා, like if you take Denmark for an example, the pollution is almost zero. They're very clean countries. But there are also majority of the countries are very polluted. US maybe, India definitely, then China maybe. There's a lot of pollution. So compared to all these countries, Sri Lanka is very less polluted. අපේ pollution ගොඩාක් අඩුයි. ඒකින්ද ගොඩාක් ලොකු impact එකක් වෙන්නේ නැහැ, but still සමහරවිට පොඩි පොඩි දේවල් එකතු වුණාම තමයි ලොකු දෙයක් වෙන්නේ. So when you light all these firecrackers, in addition to the noise pollution, there's also like chemical substances added to the atmosphere. That causes atmospheric air pollution. ඊට පස්සේ අපේ respiratory systems වලට යනවා, that will create complications later on. And also like animals lage respiratory systems වලට යනවා. Okay? Not just firecrackers, like there's this නිලාකුරු. ඇත්තටම fun තමයි. මොකද මම හිතන්නේ January 1st වල මමත් අර මෙහෙම හඳුන් පුරක එකක් තියෙන කොන පත්තු කරාම like it all lights up. So I also did that. But මම ඒක ඊපස්සේ හිතුවා wait, I shouldn't have done it කියලා. මොකද මේ ඒ වෙලේට fun තමයි, but also there's a lot of pollution. මම කියන්නේ කරාට කමක් නැහැ, but you always need to remember that everything should have a limit. There's this very popular saying that I also say a lot. ඕනම දෙයක් ඕනාවට වඩා ඕනේ නැහැ. Right? ප්‍රතිඥානම් මම ඇත්තටම හරිම against, but others also නිකන් very realistic. දැන් අපේ ලංකාවේ නම් එච්චරම අවුලක් නැහැ. මොකද අපි අවුරුදු January 1st and අවුරුදු කාලට වගේනේ වැඩිපුරම කරන්නේ. But even then, remember that it causes air pollution and it will also cause damage to your respiratory system. කන්නක් ඒක මතක තියාගෙන කරා. Okay? Is the voice range of a human in the hearing range different? Can we speak or sing in less than? We cannot even imagine. අපිට 20 hertz වලටවත් යන්න බෑ අතරම, and 20,000 hertz වලටවත් යන්න බෑ. I will show you a very interesting video. Ekeng, you will be able to get a very good understanding. Anyways, I'm like, I'm such a dog lover. So I want to give you that information and that message. Anyways, so this is our auditory range, right? So we can only... That's a nilakura. I just heard a nilakura in my neighborhood. Okay, anyways. So we can only hear sounds between 20 hertz and 20,000 hertz. So anything that is below 20 hertz, I cannot hear. And you also cannot hear. Humans cannot. Anything above 20,000 hertz, again, we cannot hear. We only hear between 20 to 20,000 hertz. So whatever we cannot hear, that means frequencies below 20 hertz, we call them infrasound. We cannot hear. Frequencies above 20 hertz, we call them ultrasound. We cannot hear, but other animals may be able to. For an example, rabbits, dolphins, bats can hear frequencies above 20,000 hertz. That means ultrasound. Rabbits lata hena, dolphins lata hena, bats lata hena. Dogs lata puluwa, ultrasound. That means they can hear up to 40,000 hertz. Up to 20, you got 40,000 puluwa. Then elephants can hear frequencies below 20 hertz. Below 20 hertz means infrasound. So they can hear that range as well. So as a summary, 20 hertz to 20,000 hertz is our auditory range. Right, this is our auditory range. So anything that is below 20 hertz, we call them infrasound. Anything that is above 20,000, we call them ultrasound. So these infrasound, ultrasound, we cannot hear, but other animals may be able to. All right. Okay. I will show you a video. It's quite interesting. I will let you hear your auditory range. I will let you hear 20 hertz to 20,000 hertz. Okay. I will have to share the screen for this. Can all of you hear me? I hope you're with me. Huh? Can you all see my screen, Lamai?
Yes, teacher.
Okay. Now listen carefully. We are starting from 20 hertz and we will go up to 20,000. So I hope you will hear. But remember, 20 hertz is the beginning of the range, but apita ahenne na 20 hertz. Then samane api gattotema, remember this also. When you take human beings, all human beings if you take human beings generally, human beings can hear from 20 hertz to 20,000 hertz. That is true. However, individually, our ears are different. I personally know that sometimes I don't hear very well, but ear ke defect it's just normal. And there are people around me that can hear more than me. And then maybe you can hear more than me, and maybe you can hear less than me. The way we hear individually also can be different. එතකොට සමහර ඔයගලන්ට පටන් ගන්න එක එක frequencies වල ඇහෙන්න. සමහර අයට ඇහෙන්න පටන් ගන්නේ 100 hertz වල. Some of you might start to hear 2000 hertz. So start the frequency where you start hearing and the frequency where you stop hearing depends on your ear. This is general for all human beings. 20 to 20,000 can for all human beings. ඔයගලන්ගේ range එක depends, right? Okay, let's start. I'll mute myself. Sorry, I can't mute myself. Then you can't hear, no? Sorry. Still, we can't hear anything. Now we hear a low buzz. Can you hear a low buzz now? බලමගේ mic එක sensitive ඇතිද කියලා. Check up. දැම්මට ඇහෙනවා. Can you all hear? A very low pitch buzz. Give me a thumbs up if you can hear. Now you can hear a little more clearly. See? Others, Metna, Mayumdi, Tinura, Metmi, Yashoda, Ashrita, Savinu, Rashmika, Risindi, can you all hear? Mm. තාමත් ඇහෙන්නේ නැද්ද? ඔයගලගේ ස්පීකර් එක වැඩි කරන්න. එවනේ නේ නැහෙන කඩු වෙනවා. තාමද?
Can't hear teacher.
I can hear me මම share කරලා තියෙන නැති ඇහෙනවා අඩු ඇත්තේ. But it will stop. Can't you hear this high pitch?
I also didn't hear anything.
You didn't hear anything?
No thing.
No teacher.
What about others?
No teacher.
Who heard? My God, that's a problem. I was going deaf here. Hmm.
But I have done this before, teacher.
Okay. Let's try one more time. I really want you all to like properly hear this. No, I don't think it's gonna work. I'm calling online class again. Make a May. I tried doing this now. No. That's the best we can do, unfortunately. But I heard some of you said that you heard, and some of you have not heard. But it's okay. I will send the link of this video on on WhatsApp. So click on that link and actually watch it. Classic වල වැඩි වෙලා යන්නේ මේක විනාඩි කොච්චරක්ද මේ වීඩියෝ එකේ තියෙන්නේ? Just 2 minutes, 2.5 වගේ තමයි තියෙන්නේ. So it's quite interesting to see the auditory range of humans and also the auditory range of you. Anyways, let's go back to the lesson. Aparade. I wonder why that happened. Anyways, let me quickly share the link of this video to your WhatsApp channel before I forget. Okay, I send the link on WhatsApp, so you can click on that link and watch it. Anyways, let's move on. So now we are going to, okay, we talked about our range. We also talked about infrasound and ultrasound. So we are going to talk about a few instances where animals use infrasound and ultrasound. Okay. So first of all, bats. Bats use ultrasound to fly during night. They emit ultrasound waves while flying. So ඒකට image එකක් තියෙනවා note එකේත්. Let's go to the next page. Okay. Bats use ultrasound waves to fly during night. Let's read. If there is an obstacle at the front, these waves are reflected back. When the bat receives the reflected waves, it can understand the position of the obstacle and avoid it. Echolocation, yes. So bat yanakota, actually we think, okay, bats always fly at night, no? So we think, okay, bats fly at night because they can see very well. But that is not the real reason. Bats la rata fly karade, their main source of communication, or their main source of checking for obstacles and like praise and all that is not through their vision. It's through their auditory sensors. ඒගොල්ලෝ මොකද්ද කරන්නේ? ඒගොල්ලන්ගේ body එකේ තියෙනවා they release ultrasound. Right? They emit ultrasound waves. They emit ultrasound waves, and though if those ultrasound waves just go, ඒගොල්ලෝ මෙහෙම ultrasound waves release කරාම if they just go, that means there are no obstacles in front of them. So bats will keep flying. Let's say there's an obstacle. Let's say there's a huge tree. So when the bat releases ultrasound waves, those ultrasound waves will hit on the tree and then will get reflected back. So bat has sensors. එයාට පුළුවන් reflect වෙනවා අල්ල ගන්න. Reflect වෙලා ආව කියන්නේ that means there is an obstacle. Because if there was no obstacle, the ultrasound waves will not be reflected, no? It got reflected means there's an obstacle at the front. Then bat knows, එයාට හොඳට පුළුවන්. මෙතන තමයි තියෙන කියලා හරියට මම location එක අඳුර ගන්න පුළුවන්. Then what it will do is it will avoid that obstacle and fly around, right? So that is one of the applications of ultrasound waves. Is that clear, Lamai? Is that clear? Hamza? Okay. Then next one, I will take this also to the whiteboard. Dolphins. Have you all heard?
Isha,
Yes.
in beach or like in ships also they use ultrasounds.
Yes, in ships also they use ultrasound. We will come to that.
Sonar.
Yes, Ashita.
In sonars.
In sonars, yes. Correct. So, okay. Then have you all heard the sound of dolphins? Have you all heard the sound of dolphins? Yes or no?
No.
Okay, others? Kind of, like they have a little bit of like this high pitch sound. Again, that's something that you can Google and find. Right? So, can dolphins have a sound? So, dolphins are that communicate කරන්නේ ultrasound waves වලින්. So, what they do is they send ultrasound waves. So, if the ultrasound waves just go, that means there are no obstacles, no prey, no predators, nothing to worry. But if those ultrasound waves go, hit somewhere and get reflected back, you're going to තේරෙනවා. පොඩි සත්තු ඉන්නවා නම් දෙනවා මේ praise ලා. Right? Reflect වෙන විදිහට තමයි ඒගොල්ලන් identify කරන්නේ. Eto reflect වෙන විදිහට sometimes they can identify large animals, then they know, that's a predator, I have to swim away. If it's a prey, ගිහලා preyව කනවා. Right? And also dolphins use ultrasound waves to communicate among each other. එතකොට dolphins ලාගේ ඇත්තටම it's not always just ultrasound waves. ඒගොල්ලන්ගේ අපිට ඇහෙන range එකේ තියෙනවා. ultrasound නම් අපිට ඇහෙන්නේ නැහැනේ. අපිට ඇහෙනවත් තියෙනවා. හැබැයි අපිට ඇහෙන්නේ නැති කොටසකුත් තියෙනවා. Right? They have a certain range of sounds that they use, but we cannot hear. Okay, that's why we call them ultrasound waves, right? I have a question. How do bats release ultrasound waves, and how do bats detect ultrasound waves? Okay, good question. Bats release ultrasound waves from their mouth, just like us, right? Because bat is a mammal name. So if you take us, we release sound through the larynx, right? From the larynx, because in the larynx there are vocal cords. Bat get Bat is also a mammal. Bat also has vocal cords. When the vocal cords in the larynx, when the vocal cords vibrate, they release sounds. It's regular release ultrasounds, and we cannot hear that because it's ultrasound. And if they go somewhere and then get reflected back, they detect the reflected ultrasound waves through their ears. Just like us. It's not sound waves, it's ultrasound waves. Okay? නැත්තම් ඒගොල්ලෝ 3D කරන්නේ larynx එකෙන් capture කරන්නේ ears වලින්. They hear through their ears. Okay? So this is about dolphins. Any questions? Give me a thumbs up if everything is clear up to this point. Excuse me, Namai.
Clear, teacher.
Okay. All right. Lamaya, for a few minutes, I'll keep my camera off. Huh? Okay, users of ultrasound. Now, the Daredevil. I have heard of that. What kind of a film is it? It rings a bell. But it rings a bell. Is it like is it like a thriller or mystery, or what kind of a genre? Sci-fi. Okay. So there's apparently a movie called Daredevil. There's a blind man, but he has a higher range of hearing. That's quite an interesting point that let's say a person, now if you take us, we are very privileged, we are very lucky because all our senses are working. Our vision is working, we can hear, our auditory parts are working, olfactory our taste parts are working, we can also feel things, skin is working, right? There are people who are less privileged. There are blind people who cannot.
Teacher,
Am I still lagging, Lamai?
now okay, teacher. Before it was lagging.
Now okay, no? Okay. So there are certain people who are deaf, right? They cannot hear. Then there are also people who cannot talk. People who cannot sense different fragrances and odors. And sometimes people with damaged nerve endings where they cannot feel anything. So if you consider let's say a blind man, vision can a more important sense, right? You have vision, but imagine staying the rest of your life closing your eyes. How would that feel? Closing your eyes, you don't see anything, or you see everything very blurred. So how would that life be? It's a little difficult to imagine, no? Because vision is such an important sense. Exactly, it feels very dull, right? And mata personally because in our school van we were passing this hospital for disabled people, and they come out every day school van and they wave at school vans. So it was very nice, but at the same time I remember thinking how could a person live as a blind man or a blind woman? During that time it was very difficult for me to understand. I was a child, but but then later, of course, I understood that there's much more meaning to life than just seeing. But still, even for now, it's a little difficult for me to imagine how life would be without seeing. එතකොට අන්න ඒ වගේ කට්ටියගේ අනිත් sensors strong වෙනවා. Blind means you cannot see no. එතකොට හැමදේම understand කරන්න අනිත් sensors තමයි use කරන්නේ. එතකොට all your other senses become stronger. I have seen real life cases. This is
Like I
scientific.
have seen people like who can see, but they are dumb and deaf.
Yes. So actually, not being able to talk is, I can imagine that. Sometimes not hearing also, I can imagine. But imagine kind of losing vision. Because like not seeing anything would be like crazy, right? But anyways, මොකද එක sense එකක් නැති වුනහම මේ disabled කට්ටියගේ අනිත් sensors වැඩිපුර වැඩ කරනවා. එතකොට there was this I can't remember who told me this story, but in Colombo apparently මගේ පෙටා හරි වගේ there was once a man, I don't know if he's still there. He cannot see, he's a blind man, but based on was it peta? I don't know. Anyways, he has this amazing talent. If a person just randomly asks him the time, he can tell the time exactly to the minute. Maybe like not exactly 19, 18, එහෙම නෙවෙයි, but 10යි 20යි 9යි 20යි. අර ඒ වගේ නිකන් අර ගොඩක් close to the real value එයාට කියන්න පුළුවන්. ඒ කියන්නේ අර සමහර ලාවට when you're blind, that sense is lost නේ. So all the other senses start working and like මුළු environment එක හොඳට study කරනවා. So he hears more, he tries to hear better. එහෙම try කරනකොට එයාගේ ear එක strong වෙනවා. Then he tries to take certain senses through the nose. Then he will try කරනකොට nose එක strong වෙනවා. Right? And then how the skin feels. Because in the morning we get a certain sensation to our skin. දවල් වෙනකොට ටිකක් රස්නේ වැඩි වෙනවා. හවස් වෙනකොට ආයෙ චුට්ටක් cool වෙනවා. There are different sensations to skin which we are not familiar. Any question? Did someone say something? Yes, class finishes at 9:30. එතකොට අපිට ඔක්කොම තියෙන හින්දා අපිට අර එහෙම එච්චර දැනෙන්නේ නැහැ, but if one sense is lost, your other senses will start working better. Anyhow, yeah, so that's a very I think useful insight, ne? Okay. So I have some more. That film gets powers by radioactive materials. He became blind but receives higher range of hearing, like he sees through sound wave. Oh, like radar. Daredevil. Okay, I'll try to watch that. It's like to cover up for that lost sense. Yes, that is exactly right. ඒ කියන්නේ නැති වෙච්ච එක cover කරගන්න අනිත් senses හොඳට වැඩ කරනවා. We can see dolphins communicate each other in Finding Dory. Yes, that's correct. You may have watched, no? Finding Dory. ඔයගොල්ලෝ බලලා තියෙන නේද ගොඩක් අය. So, even if it's not, just try to watch a video, like whales la communicate kind of sounds, dolphins la, it's quite interesting. Anyways, uses of ultrasound, one use is to find the depth of the sea. For this, an instrument called sonar. Sonar කියන කෙන්නේ SO from sound, N from navigation, A from and R from ranging. So SONAR, sonar. So this system is called the sonar system. This instrument is called sonar. ඒක ගහන්නේ හැමලෙම ship එකේ යටට, right? So there's a transmitter and there's a detector. Transmitter එකක් වෙනම තියෙනවා, detector එකක් වෙනම තියෙනවා. What the transmitter does is transmitter releases ultrasound waves. දැන් ඇත්තටම මේකේ system එකේ purpose එක මේකයි. Let's say a ship is traveling in the ocean. ගොඩක් වෙලාවට coastal areas කියන්නේ land වලට ළඟ areas නේ. Ships don't always travel in coastal areas, no? Sometimes the ships have to go through different areas of the sea. Sometimes it could be like in the deep sea area. Sometimes it could even be coastal area. So okay, keke areas will yandone. Yanakota, the ship sailor has to manipulate the engine, control the engine in different ways. So for that, it's very useful to understand the depth of the sea at that particular place. Then කොහොමද නිකන් random තැනකදී depth එක බලන්නේ? Are they going to put a meter tape or something downwards and see where it ends? Or is somebody going to swim all the way down there and find the depth? No. එතකොට අන්න ඒ වගේ වෙලාවට ඇත්තටම practical solution එකක් නැහැ. But when technology improved, now we have a practical solution that is what we call sonar. Sonar එකේ වෙන්නේ ultrasound waves are like this, right? There's a transmitter. Transmitter releases ultrasound waves. So these ultrasound waves මෙන්න මෙහෙම පල්ලෙහාට යනවා. ගිහිලා කොහේ හරි depth එක තියෙන තැන ආ වැදිලා it will reflect no. එහම reflect වෙලා එනවා. දැන් reflect වෙලා එන ඒවා capture කරගන්න we have a detector. Transmitter එකෙන් release කරනවා, they hit on the bottom of the sea and then they will get reflected and the reflected ultrasound waves will be captured by the detector. Okay. එතකොට අපි බලනවා කොච්චර වෙලාවක් ගියාද කියලා මේකට. You can go to the next page. There's a question also. හරිද? Now let's take an example. අර question එකම තමයි මම discuss කරන්නේ. Now in the ship the transmitter releases ultrasound waves. ඔන්න දැන් ship එකේ ඉන්නවා මොකද X කියලා location එකක. Let's just take an example. Now the crew wants to find the depth of the sea at that particular place. Then මොකද කරන්නේ? They activate the sonar system, right? They activate the sonar system, so the transmitter will release ultrasound waves. So ultrasound waves will go down and come up, and in ultrasound waves take a detector can capture karna. Let's say for this entire thing, it took the total time taken was 4 seconds. Okay, and also speed of sound in seawater is 1500 meters per second. Now we have a very useful equation. What is it? Speed equals distance divided by time. Now speed I know 1500. Speed is a known value. It's something that is known. Distance I don't know, but time it's 4 seconds. So distance will be 1500 multiplied by 4. Therefore, distance will be 6,000 meters. Therefore, depth of the ocean, depth of the sea will be 6,000 meters. What do you think of this question and this answer? Is this correct? Did you understand this? What do you think about this? Any comments? Is my answer correct or not? Is my answer correct or not? Others?
No, teacher.
Why? Because I took the time. Correct.
Both to go and touch the depth and to return again.
Yes. So time was measured as so both journeys took 4 seconds. Our distance made total distance. If that is 6,000, I only want one way, right? Now, if you take 6,000, that is to go down and to come up. I only want one. So, therefore, depth of the sea will not be 6,000, it will be 3,000.
Divide by 2.
Yes. It will be 3,000. එහෙම නැත්නම් උගන්න මෙතනදීම කෙලිම time එක 4. If the total time is 4 seconds, that means එක journey එකට ගියේ 2 seconds නේ. So එතනදී මට කෙලින්ම ගන්න පුළුවන් speed equals distance over time. Speed is 1500 ms minus 1. Distance is d, time is 2 seconds. So distance will be 1500 multiplied by 2. Therefore, distance will be 3000 meters. කියලා හැම ගන්නත් පුළුවන් මුලදීම time 2 වලින් divide කරලා නැත්නම් at the end you can divide the distance by 2. Is that clear, lamai?
Yes, teacher.
Okay, others, give me a thumbs up. Okay, let's wrap up here because our time is up, but I think we only have like 30 minutes but naha moka the ultrasound waves wala user sticker harima simple. We talk about that and we talk about the musical instruments, probably like 15 to 20 minutes. The quiz we will definitely do next week. It will be roughly around 10 to 15 minutes. So also right now after the class, I will send you the biological processes note. So ඒක ඇත්තටම ටිකක් ලොකු note එකක් because there are 5 systems that we are going to be learning. So you have to take a printout. So what you can do is එක්කෝ ගන්න මුලකම you can take the entire printout together all at once. That's quite a lot of pages. If not ඒ දවසට අදාළ කොටස print කරන් එන්න. But I would suggest, I mean, anyways, you have to print the whole thing. So better to print the whole thing. But it's totally up to you. I will send the entire PDF. So next week, we are starting the digestive system. We will not be able to finish it, but we will start the digestive system. Komat may 6th sanakata මාසයක් යනවා. So brace yourselves for that. And yes, quiz එකට හොඳට prepare වෙලා එන්න. Quiz එකේ marks හැමෝගෙම මම වෙනම mark කරනවා. I told you all, did I tell you
It's chapter 1 and 2, right?
1 and 2? I don't remember if I told you last week, but I will be selecting, I will be doing a little bit of a, like a judgment situation where like, I will consider your quiz marks, I will consider your attendance and all that. But like seriously consider that. හැමෝගෙම individually මම වෙන වෙනම බලනවා කොහොමද quiz marks, how's your performance during the class, how do you answer questions, do you interact well during the class, do you come to classes regularly. මම එක individually ම check කරනවා කියලා හිතුවා. This is something that we planned in April. Mainly because of the attendance situation, but also ඒ කියන්නේ ළමයිගේ attendance මට හරි consistent බවක් ගොඩක් අය consistent, but there are a few whose attendance is not very consistent, which is not something that I really like. ඒකින්ද තමයි මම decide කරේ. So attendance කොහොමද බලන එකේ I thought I will also properly evaluate your performance. So again, brace yourselves for that. ඒකින්ද please perform well. Always prepare and come to the class. Take the classes very seriously. You're not
Teacher, do we have class next week because it's a 4-year day?
I will be holding the class actually because අපිට holiday එකක් ගන්න බෑ. One second. Like next week is Vesak, no?
Yes.
No, next week is like not the Vesak day, it's the day after Vesak, nene? Vesak is on 1st, right? So 2nd is the day after Vesak, so no problem. Let's have the class as usual. මොකද අපි අර මට මේ අවුරුද්දට කලින් Saturday එකේ මම class එක කරන්න හිටියට due to unavoidable circumstances I was not able to do, which I feel very regretful about. මොකද මම අනිවාර්යෙන් කරන්නමයි හිටියේ. ඒකින්ද අපි අනිවාර්යෙන් next week class එක I can't give holidays. And I will be doing the quiz for sure. So please attend. එන්න බැරි කට්ටිය I need your parents to call me. Okay, then let's wrap up, lamai. I think that's all I have to say. Yes, let's wrap up and let's meet next week. study and come. First 2 lessons, biology, it's not that much of a deal. And let's do the quiz properly. Let's start with the quiz. And yeah, let's meet next week. Until then, have a great week, Lamai, and good night.
Good night, Miss.
Okay.